My name is Jason Silverglate. I'm President and CEO of Dedicated Now. We're a managed dedicated server hosting provider out of New Jersey. We've been in business for 13 years, privately funded, no VC, nothing like that. First, let me ask some questions from the audience. Who here is looking to deploy to cloud? Can you raise your hand? Okay. Good. Let's get started. What are the key components to a cloud? You have the servers, you have the network, SAN storage, your hypervisor, and your cloud management platform. So we'll go into each one of these modules, essentially, to help you put together your cloud that you want to build to service your customers and your market. Servers, chassis, price per gig, price per kilowatt, price per U, vendor. Chassis is a very important decision. You can either have a blade, you can have a 2U, you can have a 1U, you can have a hybrid blade where you have a 1U chassis with 2 blades, a 2U chassis with 4 blades. Depending upon your density you're looking to achieve, whether you own your own facility or you co-locate, this plays a very important factor in building your cloud. Your price per gigabyte. The gigabyte RAM, essentially, is RAM. But the thing is, this is the one resource in the cloud you really can't oversell very efficiently. It's the one resource that is your limiting factor in your cloud architecture. So what is your price per gig when you're considering the server? And how much RAM you're going to allocate to each of your clients? Price per kilowatt hour. Or price per kW. Depends on how your data center is pricing it. Some data centers charge $250 to $300 per kW allocated to your rack, plus power. Others just charge a rack fee up to a certain amount of amps, plus power. So all these come to play when choosing what type of server you're looking to deploy. And price per U, of course, how much does the rack cost? How much CPU, how much RAM, how much density can you squeeze into U? Once again, you might be limited by the actual heat rejection capacity of the data center you choose. What manufacturer? Dell, HP, Supermicro, etc. We'll go into that later. The network. You have your private network, you have your front-end network, and you have a storage network. 1 gigabit, 10 gigabit, InfiniBand, and fiber channel. Each of these play a different role in the different segments of your cloud infrastructure. SAN storage. IOPS, RAID, Enterprise SAN, and other alternatives. IOP is a magic word. Who knows what IOP means? Anybody? Nobody knows what IOP means. Okay. Interrupts per second. Basically, it's how many requests that hard drive, that SAN storage array, that enterprise array can handle. How many requests per second your clients can send to your storage backend. The more IOPS, the more clients you can handle. RAID. RAID 10, RAID 5, RAID 6, RAID Z, or some other sort of raiding mechanism. Enterprise SANs, do you want to go with the Dell low-level EMC array, equal logic, large EMC, 3-par? These are all questions you're going to need to answer based upon what type of customer you're looking to go after. Alternatives are, like an OpenE or an Open Solaris, ZFS type of SAN storage array. Hypervisors. There are a lot of hypervisors to choose from. The question is, once again, what type of customer are you going after? You don't have to choose one. You can choose multiple hypervisors in your infrastructure, depending upon what type of client you're going after again, and what type of cloud management software you're using if it can support that hypervisor. We have a choice of a few hypervisors. You got Cloud.com, you got OnApp, Ubiquio, Anomaly, or you can roll your own. So we'll get into each one of these as we go into the presentation. We'll skip this. What type of cloud are you looking to build? Who is your target customer? Are you going after the financials? Or are you going after the small SMEs? Or are you going after the enterprise? What is your target customer? Replacing infrastructure. When you build your cloud, what's your mean time to repair a down component? Can you get another switch in there quickly enough? Can you get another blade in there quickly enough? Do you have spares on site, or do you have to call Dell and HP to come and fix them? What type of standards are you looking to achieve in your infrastructure? Are you going to try to go after SAS 70, PCI, HIPAA. Some of these can be done in a cloud, traditional cloud. Some of these can't be done in traditional cloud. Depends upon, once again, your infrastructure choice, the security your infrastructure implements, and the redundancy. SLA. What type of SLA are you looking to offer in your cloud? Not 5 nines, 4 nines, 100%. The SLA you choose will dictate the rest of your infrastructure. This is pretty much the first question. These two questions are the first questions you need to answer. Who is your target customer, and what type of SLA you want to offer? RAM, at this moment, can't really be oversold efficiently in the cloud infrastructure. You deploy a blade, a node, with 48 gigs of RAM, you go and put 48 1-gig clients on there. But nowadays, Zen just released actually Zen Server 5.6 with what's called RAM ballooning. So, as you know, Citrix Zen Server is free, the base version. And it is supported in that. So does your cloud management software support it? And how much over allocation are you going to allow your customers to do? VMware supports RAM ballooning. Hyper-V supports some RAM ballooning. KVM doesn't very well, not yet at least. But Zen open source does not. But RAM typically can't be oversold, and if it can be only oversold a little bit. Calculating your cost for the RAM. There is cheap RAM, there's expensive RAM. How much RAM you can put in a system? 4 gig DIMMs, 8 gig DIMMs. I think they even make 16 gig DIMMs now. This all goes in play in what your price per gig is, and then what you charge your customers in the end. Total cost of ownership. Network cards. Now here we're getting down to, we're still talking on the server. So you got 1 gig, you got 10 gig, you got InfiniBand, you got fiber channel. You also got fiber channel over Ethernet, usually over 10 gig. A 10 gig card using TwinMax, which is max, I think 7 meters long for the 10 gig fiber. Each card runs around $400 to $500 for a dual port. Obviously, a 4-port card, you can pick a 4-port gig card, you can pick up for around $100 to $200. So, based upon what type of customer you're looking to go after, once again dictates the type of infrastructure you're looking to deploy in your servers. InfiniBand cards mixed with 10 gig E, Mellanox has those. One InfiniBand may be for your storage side, and 10 gig for your public IP side. But that leads to other problems based upon what type of server you choose. You're not going to have any sort of network redundancy on the server, so you won't have 2 links into your fabric. Software. If you're going to be rolling your own, what's your cost to roll your own versus what's your cost to procure one from one of the cloud management software providers we mentioned. Your cost per port for the switches. If you're going to go 10 gig, you have your Cisco Nexus series. You have your Arista networks. I'm not sure you guys ever heard of that. Who's heard of Arista networks? Anybody? Anyone use Arista networks? No? In my opinion, they're absolutely fantastic. Price per port and performance. Cisco Nexus ones are serious backorder and seriously overpriced in my opinion. So if you go with 10 gigs, those are my 2 suggestions. And if both of them do stack, so they'll give you the network redundancy that you're looking for. For the 10100, 1 gigabits, you can choose Juniper or Cisco again. I personally prefer the EX4200 series. This gives you layer 3 capability with stacking. Comes in 24 and 48 port modes with 4 fiber ports or 2 10 gig port uplinks per module. Warranty. If it's Supermicro, you usually can replace it, build it yourself, and replace it very quickly. If you're using Dell, HP, well, that server, that node is down for 4 hours or 8 or next business day, depending upon what type of arrangement you have with them. I prefer Supermicro, honestly. Once again, replacement parts. How fast can you replace your server? What's the cost to replace a server? You buy a server from Dell for $2,000. Warranty is additional $800 for the server for next business day or 4 hour on-site repair. What's it cost to have another motherboard on site for a Supermicro box? But once again, what type of customer are you going after? They might want to see the Dell name. They want to see the HP name. Ease of repair, how fast you can get your nodes back online, how fast you can fix your infrastructure, how fast you can restore your system to full 100% capacity. Deployment, how fast can you deploy new systems? How fast can Dell get you a new server? How fast can HP get you a new server? How fast can you build a Supermicro server? Because if you have a strong growth rate, these are all considerations you need to have. Power consumption. They say blades use less power per core. They probably do. However, most facilities, if it's not your own, you'll only be able to get 1 or 2 blade chassis in an entire rack before they start hitting you for exorbitant charges on the colocation fees. So does it really give you any benefit to spend the extra $5,000 or $3,000 on a blade chassis versus going a Supermicro route in terms of a 2U 4-bay blade system, which usually accomplishes the same density at a fraction of the cost and at a fraction of the power consumption? Colocation. Do you own your own facility, or do you colo? How many people here own your own facilities? How many people collocate? So if you colo, how fast can they get new racks online for you and deployed? And whether they charge you for a rack, and whether they charge you for more power, whether they charge you for density. A lot of the major facilities are still considered legacy facilities. They have a certain power cap that they can handle per square foot. 100 watts, 150 watts. You start going blades, you're pushing 200 to 300 watts per square foot. They just can't handle that. Some of the larger legacy facilities. If you own your own facility, well, you can do what you want. Server providers, as I mentioned, Dell, HP, Supermicro. These are some of their blade systems. This is, I think, 14 servers in 10U. It's a great system, very expensive compared to rolling your own Supermicro gear network. This is probably one of the most important decisions you're going to have to make in your cloud, your network fabric. Now, as I mentioned before, there are 3 network fabric segments: your public IP, your private IP, and your storage. Total network fabric capacity. If you're going to go split up into those 3 routes, you can either have them individually, i.e. have your private be a gigabit or maybe 2 gigabit private network, have a gigabit or 2 gigabit storage network, and have a gigabit or 2 gigabit public network. But if you're getting 30 to 40 nodes on your machine, how much traffic are they use? Are you deploying complex web applications? Are you deploying complex database applications? What are you deploying in the cloud? What are your customers deploying in the cloud? What services and products are you offering in the cloud? We have customers that push a gigabit of just database traffic. Just database traffic. So imagine that in a cloud infrastructure that is under-piped, essentially. Doesn't have enough throughput. It'll choke off your other customers. Storage network. Some people say you can get away with a gigabit. Some people say you can get with 2 gigabits. Depends, once again, depends on what you're pushing through there. InfiniBand is kind of like an extension of the PCI bus. So essentially what you're doing is you're extending the server's motherboard to the storage stack, to the SAN. It runs at 10, 20, and 40 gigabits per module. So a 10 gigabit or 20 gigabit InfiniBand dual module redundant gives you 40 gigs into your storage fabric, which is more than enough. The question is, can your SAN handle it? Can your SAN's throughput support it? Fiber channel, most enterprises go fiber channel just because it's what they like to hear, what they like to see. You have 8 gig fiber channel, 4 gig, 2 gig. I think there's 6 gigs somewhere in there. One thing about fiber channel, which I don't like, is the costs. The cards are just okay, but the switches have low density, and they're very expensive. But also the throughput just doesn't compare to a 10 gig or dual 10 gig or a dual InfiniBand setup. iSCSI and NFS. iSCSI and NFS are protocols for storage. You can run them over a unified IP network. For instance, you can take a hypervisor node, one of the servers, two 10-gig modules into it, into one fabric. So you have 20 gigs into your fabric. So you can run your private, your IP, and your storage network all over the same pipe. And within that pipe, you run iSCSI, you run NFS. That gives you 20 gig of total throughput capacity to your hypervisor nodes. Storage. This is also a very, very important factor in your decision, what type of customer you're going to be getting, you're going after. Enterprise storage, homegrown storage, redundancy. You go with like an IBM XIV, or you go with a 3PAR, or you go with the EMC. They're going to run you each $100,000 to $200,000 at least for one unit. That is internally redundant, yes, but not redundant chassis. Most of these units only support fiber channel or have limited expansion on a 10 gig basis. How many IOPS is your storage backend going to support? How many IOPS, once again, is how many requests per second your system can handle, your SAN can handle. The more IOPS you can handle, the more clients you can throw on the SAN. 70-30 rule. 70% of your requests to your SAN will be write, 70% will be read, 30% will be write. That is a typical rule for your SAN traffic. So when you test SANs, benchmark it off of that. SAN to fabric throughput. What we're doing is we have, for our cloud deployment, we have 40 gigs into our fabric from each SAN. And your host to fabric throughput. Once again, what we're doing is we're doing 20 gigs from each node to fabric. So what that says about what does that say about what type of customer we're going after? The customer who's looking to deploy complex web applications in the cloud to handle serious web applications. 3PAR, one of the pioneers in what's called thin provisioning. How many people know what thin provisioning is? Okay, Daniel, you know, right? Thin provisioning is when you allocate a customer in the cloud or in any environment, you present to them 100 gigs of storage, yet it only uses, say, 10 gigs of storage on the SAN, but the customer sees 100. So that gives you the ability to oversell your storage. In most SAN environments, whether using like OpenE or regular RAID, what you allocate the customer is what they get. Out of your SAN, even if it's unused, it's sold, it's no longer a resource you have available to you to sell. Some of the hypervisors have natural thin provisioning built in, like Zen does, where it grows the image. However, it puts, in my opinion, it puts a lot of overhead on the actual VM. So your clients will notice a slowdown versus a provider that does not grow the image dynamically. IBM's XIV solution, we'll skip EMC for now, is they acquired that company about a year or two ago because it essentially uses commodity hardware to build a redundant SAN. They're using 1 or 2 terabyte Seagate SAS drives running at 7,200 RPM versus EMC's mostly using fiber channel, SAS, or SATA drives. They usually cap out at 600 gigs. ZFS solution, this is my preferred solution, is ZFS. Basically opens Solaris with ZFS, gives you thin provisioning, gives you RAID Z, and in my opinion, it's a lot faster than any sort of other commodity or off-the-shelf solution you can buy at a very cost-effective price. Once again, what type of client are you going after? Do they need to see 3PAR? Do they need to see EMC? Do they need to see XIV? Your hypervisor. So which route do you want to go? Who are you going after? What is your target customer again? VMware, Zen, KVM, Hyper-V. Hyper-V Core is free. I don't know if I'll let you know that. Hyper-V Core is free, so there's no GUI, there's no Windows OS on top of it. It's just all command line based. VMware has a great partner program. Zen Server or Zen Source and KVM is coming up pretty fast as a viable alternative. So who do you want? Who's your customer, and who are you going after? You want an open source solution? Support. Is there good community and vendor support? Can you go on the message boards and Google and Google groups? Can you find your solution to your problem if you have a problem? Who can you call if you have a problem? How well trained is your staff in fixing the problems? And can they get support if they need to? That might dictate what hypervisor you choose. Also, the features. VMware has right now some very, very good RAM ballooning or RAM bursting. Also, as I said, Zen Server is coming out with it very shortly. KVM has it a little bit. Scalability. Who gives you the best CPU performance? There have been a lot of benchmarks done between Zen and KVM as of late. Zen is just squeaking by in terms of storage performance being superior. However, head-to-head on the IP performance going to the public, Zen and KVM are pretty much neck and neck. Which one's easiest to use? Well, that's your decision. What is right for your group of, what is right for your group of techs? What does your techs know? What can your techs do? Cloud management software. These are just a few cloud management software providers out there. You might have seen some at the show today. The Strip, got Cloud.com, OnApp, and that's it who's actually here. We've demoed most of these and talked to most of them. So Ubiquio is a Spanish company. The platform is a little immature. It's not quite ready for what I would consider a true hosting environment. Maybe for enterprise, it's quite good. Flexiscale is a UK group, a hosting provider who's decided to spin their cloud software out for public consumption. It looks pretty good. We have not demoed it so much. Cloud.com, originally VMOps. They're here at the show. Their product is actually pretty nice. However, they're a little slow on some of the key features that us hosting providers do need, like direct IP storage, direct attached IPs, and some other network-centric features like multiple VLANs, multiple Ethernets in each VM. Anomaly is one of the oldest cloud management platforms out there. They are the, I think, sponsors or founders of Cloud Group on LinkedIn. So they have an interesting solution for, if you're going to the financial marketplace, they have a very interesting solution. Their cloud platform integrates with Intel's security VT chipset or something like that, where it verifies that the hypervisor image has not been tampered with and is the same as it was before. So it provides some sort of level of security that the image is the same as what that was before. OnApp is designed by a hosting company for hosting companies by ex-UK2 people, and is integrating with hosting billing platforms that we all know and use, like maybe Ubersmith or WHMCS, Client Exec, et cetera, et cetera. And I went through all this before. So does anyone actually have any questions we can go back to and cover for you? No questions? On our storage network, we are using 10 gig Ethernet. So we're doing a unified storage backend, unified IP backend, essentially. So if you use iSCSI or NFS, that's an IP protocol. So we have 20 gigs from each node into the switch fabric, where we have 2 Arista switches stacked and completely redundant. So if one fails, we still have 10 gigs to the switch fabric. And then the SAN is connected via 40 gigs, so 20 gigs to each Arista switch. And we have 2 SANs. Well, latency obviously is very important for storage, yes. But that brings a very good point, Daniel. The one thing that was not in this presentation, which I neglected, I'm sorry to say, is quality of service for your back-end networks. For instance, if you're looking to deploy high throughput database applications, high throughput web applications, you need some sort of QoS on the back-end network. So some platforms here have QoS capabilities where you can limit them to a certain type of throughput, not necessarily how many IOPS they can use, but how much throughput that VM can use. So you can give that VM 1 gig into the storage fabric, 10 gigs into storage fabric if you want. You can give them the growth that they need while not affecting other clients. What you really want to watch out for is IOP hogs. So pretty much anything that can really overload your storage, and will happen. Some people who launch prematurely without any sort of QoS in the back end have been brought down by people just destroying their storage fabric and the actual storage nodes themselves. So that is why we have opted to go the 10 gig route as opposed to a single multi-gig route, as opposed to handle the type of clients we're looking to go after. Our SAN is capable of doing 1,600 MBS of read and 1,500 MBS of write, which is in gigabits is essentially 16 gigabits of read and 15 gigabits of write traffic from each SAN. And essentially, what we're doing is, because we have redundant SANs, we can do MPIO. MPIO is multipath I/O, which means that each hypervisor node can take 2 paths into the storage nodes, into 2 storage nodes, or 1 storage node, depending upon how you have them configured. So that gives them 2 points of entry, two paths, and 2 separate fabric bandwidth, essentially. Christian? Good question. As I mentioned before, we are a dedicated hosting provider, so we provide dedicated servers. However, as server speed and server capacity just gets higher and faster and cheaper, customers' need of these resources, they'll never attain them. They'll never be able to use all the capacity of these servers, or at least most customers, 95% of customers, will never be able to use all these resources and all these servers. So if you can provide them a higher level of reliability, faster CPU speed, more uptime, more faster storage fabric, then for the same price, then why not? And also power savings. For instance, we have several thousand legacy dedicated servers from way back in the day, like Celeron 1.7s, P4 2.4s. They just, the customers are there, happy to take their money, but I want to offer them something better, some higher quality service. And also, by moving these thousands of servers into the cloud, I lower my power bill significantly. I get resources back in my infrastructure. I get KW back on my UPSs. I get KW back on my generators. I get more tons of air conditioning back in my systems. So henceforth, I can deploy more clouds or more profitable dedicated servers. Yes? We went with the ZFS route. We are using, one thing about ZFS, which is separate from these guys and separate from maybe like just a standard RAID setup, is that ZFS allows for SSD read and write caching. So we have essentially we're using 2 terabyte SAS drives with dual SAS ports on them. So we have MPIO within the chassis itself. And we're doing SSD read caching and SSD write caching. That's how we're able to achieve such high IOPS and such high throughput in our SAN at a fraction of the cost of what our friends here would charge. Zach, yes. I was waiting for that one. I think I'm a little worried. I'm a little worried, but I think that it will pull through. There's too many resources invested in it across too many companies for it to just go away. So I'm worried about the short term, but not the long term. Any other questions? Okay. Yes. Yes, everyone does their own personal definition of cloud. That is a good one. Before I do that, what is your definition of cloud? Okay. Okay, that is the client side. What is your service provider definition of cloud? Okay. Very good definition. I guess I'll tell you mine. My definition is very similar in terms of the more theory of what your idea of cloud is, what cloud means to you. My definition of cloud is more along the lines of, yes, that theory, but more along the lines of what type of infrastructure we deploy underneath it. Because the customer, all the customer sees is a block of resources. Some people take a VPS server running Virtuoso and say, hey, I'm a cloud hoster now. This is cloud. That's not, to me, that is not a cloud. That's just a VPS, maybe with a pretty GUI. So a cloud to me is this. This is what the cloud is to me. Essentially, you have a network of servers. You have a fabric to support the servers, network fabric. You have SAN, redundant SAN storage. And you have your hypervisor of choice. So you have all these resources put together to provide a fault-tolerant, resilient infrastructure that if one hypervisor goes down, one server goes down, everything, the customer seamlessly moved over to a new environment and rebooted and back up and running. That, in the olden days, I guess you can call that a VPS on steroids, before the whole cloud term came about. But that is what a cloud is to me in terms of infrastructure. Being able to give customers unparalleled uptime, unparalleled availability, and unparalleled speed of resources. For instance, if they grow, they set, when they hit 8% resource allocation, scale me up another core, or scale me up more RAM, scale me up. That is what cloud is to me. These are things that really you can't do in a VPS, a traditional VPS environment, because you will hit a cap of that machine eventually. In a cloud, the resources are there. You can move to another machine with resources available using live migration. You can't do that on a VPS with a VPS node with standard storage, local storage, and without a heavy fabric in the back end, and without a SAN. Dan?
How large? So you're getting, in the end, you're saying you were motivated to do this because you can consolidate a bunch of the smaller hosts, smaller dedicated, and make more money. At what scale do you need to be in order for this to become as profitable or more profitable than typical dedicated? There's obviously a lot.
There is a barrier to entry, yes, depending upon how you're going to do it. If you're going to do it right, it's 6 figures. It is. There's no questions, ifs, ands, or buts about it. It's 6 figures to do it right on a small scale. Even like 10 nodes using, Open Solaris and Supermicro gear. It's 6 figures. It's not cheap. However, if you want to do it in the cheap and you want to provide a very elementary cloud environment, take a 16-base Supermicro server, throw a RAID card on there, throw OpenE on there, get a couple hypervisors, get OnApp or some other cloud platform, and use Gigabit. And with the service, the standard generic VPS, marketplace. But what we designed this for is as a replacement for dedicated servers. That is what we designed our cloud for, to truly replace what a dedicated server can do. So if a customer has a Core i7 equivalent, they need, say, to upgrade to a Xeon, they're upgraded.
So at $1 million of investment, is that actually replacing, what that translates to an operating cost? Is it actually more profitable than the equivalent investment in dedicated servers? Or do you
Yes.
have to do a larger scale?
It's equivalent. We not just in the economies of scale in terms of what you'll save, operating speaking, in terms of electric bills. We're located in New Jersey, so we're one of the most expensive areas for electric costs. We're typically twice that of what Seattle is, Texas, Atlanta. So by us moving these servers to the cloud, we'll save somewhere along the lines of $20,000 to $30,000 a month in electric bills. So that is a strong motivating factor for us. So Zach, question for you. What is your definition of the cloud? Any questions? Comments? Holes? Yes, they are. If you'd like, I'll email them to you as well. Okay. Oh, yes. We built ours at a certain size, but ours is very, very scalable. Ours is extremely scalable because the way we design our storage platform, we can just tack on more shelves into it. And the beautiful part about ZFS is that you do it in stripes, in like RAID groups. And with 6 gigabit SAS and multipath I/O, 2 paths into each hard drive, and redundant paths into each chassis, our storage backend can probably support around 300 nodes, 400 nodes, with each node running anywhere between 10 and 30 VMs. Depends upon obviously what the customer purchases. But I doubt we'll even make a dent in our fabric of 20 gigs to each node. We only hit a dent in it. The only reason we're overbuilding is because we feel that somewhere in there's going to be large database applications. There's going to be large bandwidth hogs that will use maybe 20% of it 30% of it. Everyone else will probably only use a gig max, gig to 2 gigs max of the fabric itself. However, to risk going with a 1 gig fabric, the costs when you start adding on more gigabit switches to handle this almost come close to what your cost would be for a 10 gig backend. And then, depending on what type of chassis you choose, how many single gigabit Ethernet cards can you really get in there? So if you go with the blade route on maybe get a single PCIe card in there with 4 1 gig ports with 2 gig on board, so that's 6. That's 222, 2 storage, 2 public, 2 private. For some, that's not enough. Well, a lot of clouds are different. We'll come back to this slide where I skipped before. There we go. These are some of the clouds that are out there today. Start with Navisite. Navisite is using IBM XIV with Fiber Channel, and they're using VMware and Zen, I think. They invested a lot of money in this, and when I talked to some of their tech people, the applications they're running in here are basic, generic, small-time web applications. There's nothing traffic-heavy. When I asked them if your infrastructure can support an Oracle database or anything of the sort, they were not sure that it can handle it. Just not so much from what the IBM XID can do, what their backend storage fabric can handle and what their capacity to each server can handle. The Planet is using KVM with, I think, a homegrown system. And they're using Sun storage with ZFS. They're not using like a Supermicro chassis running over Solaris. They're actually using Sun storage with ZFS. So they're taking a similar approach to what we're taking. But I do not think that their infrastructure isn't 10 gig. So I don't think it can handle a large database application either. VPS.net up to recently wasn't redundant in terms of their storage backend only had a single SAN running OpenE with 10K SAS drives. They've since migrated to redundant OpenE SANs with the Datex Max IQ for SSD caching. And according to them, it's working out well. And they're only using a couple gigabits on the back end. Once again, their system isn't designed to handle heavy complex clusters. Theirs is designed to replace the Virtuoso market, the VPS market. That's what theirs is designed for. LiquidWeb is a different story. They're all essentially just, you might want to like me saying this, but VPS on steroids. All the storage is local. If you want any sort of failover or any sort of liability, you need to purchase backups, and that will back up to a SAN, and then you need to go ahead and initiate a failover request to have it restore the image from the SAN to another node. So in my definition, it's not so much as a real cloud. It's more just VPSs with a very amazing GUI. I'll give them credit for that. Amazing GUI. Giganet is running a 10 gig back end with OpenE, I think, if I recall correctly. And they didn't have any QoS, so they ran into a lot of problems with VMs eating up their back end. They ran into a lot of problems, so they're trying to implement the QoS now into their systems. So, any other questions? Once again, my friend.
Investing a lot that will only be relevant to a fraction of your clients. So
right.
If you just sell cloud nodes with all right, these are ones with more limited backing, more limited IOPS.
Right.
These are ones with more. Seems like that might be a more efficient target.
Well, yeah, you can definitely go ahead and allocate different shelves in your storage array. Depends on what type of array you use. You can have a 1 terabyte standard SATA shelf running at 7200 RPM with no MPIO capabilities. You can have a SAS storage shelf at 10K or 15K. Then you have a 2 terabyte SAS with 7200 RPMs with MPIO capabilities. Once again, it comes down to what type of services you're offering, what type of customer you're going after. But this is all classified as essentially tier 1 storage, which means it's the storage that your operating systems and your critical data lives on. However, you can implement tier 2 storage into your environment, whereas you have your database and your OS booting off of tier 1, and your, say, your images directory and your home directory or static files that aren't getting written a lot in more of like a GFS environment or some sort of other parallel file system like Parascale or MaxiScale, whatever the guys are. So you're looking for a commercial solution. So you can mix and match different storage platforms in your cloud, providing A, your cloud management software supports it, or you roll your own and you support it, or you hack it up.
Yeah, I was thinking as much also in terms of having 1 gig, 1 gig nodes versus 10 gig nodes. So every node to be 10 gig node, if you just make sure that anyone who's allocated
Right.
large enough cloud nodes is on the 10 gig.
Your cost delta is high, but I'm not sure if it's so high as to run 2 separate infrastructures. Because you still need to have the 10 gig to the SAN in your switching fabric, whether you have gig to the hypervisors, the nodes. So you need 10 gigs to SAN, which is perfectly fine. The EX4200s have 2 10 gig ports on them, but then you need to have 1 10 gig port, obviously, back into your core infrastructure for outbound IP.
I guess I would think you wouldn't necessarily have 2 separate infrastructures because you set up one.
Well, yeah,
But you would need a management layer that's savvy about that.
exactly. Yeah. Any other questions? No? Thoughts? Yes, sir. We actually running redundant SANs. So we have 2 SANs sitting next to each other that are connected via 6 gigabit SAS, as well as the SAN head nodes are connected via multiple 10 gigabit links. And they do replication between each other. And they're also dual paths. So if one SAN if the head node completely goes down, the other head node can control both storage arrays. So we are completely and totally meshed on our back end. There's no single point of failure in anywhere. Even 2 points of failure at all in the storage back end. Any other questions? Okay, then. I'm Jason Silverglate, President and CEO of Dedicated Now. I thank you for your time.